Avl trees are balanced search trees, and it's named after its inventors. Its inventors are Edelson, Welsky, and Landis. So AVL, Edelson, Welsky, Landis. Nice to meet you, Avl Trees. So what is a balanced search tree? Balanced search tree is a tree where the nodes are organized on a tree, but in a way where it's very close to overflow FN. Meaning, let's imagine for start a non-balanced tree. To imagine a non-balanced tree, then we need to imagine like a full not balanced search tree. We would get a straight line. Just imagine a tree which does not look like a tree, but it's a valid tree. It's a valid binary search tree. It's sorted on a straight line. If we insert the nodes, the values 1, 2, 3, 4, 5, each one as the right child of its parent, then we would get a non-balanced tree. And now let's move on to the intuition of how to balance such binary trees, specifically in the Avl method. So the best way to balance such trees and to get the intuition for it would be to imagine this non-balanced tree. We have a straight diagonal line, and let's balance it. So, and still keep the properties. So imagine you take your finger, your hand, and you pull the middle node. So we have the straight diagonal going to the right line, which is a valid binary search tree, but it's very not balanced. So you pull the middle node with your hand and you pull it up, just like as if you had a line and nodes, dots on the line, and you just pull up one of the middle nodes. What would you get if you pull up the middle node? You would get half of the nodes going to the right. The middle node that you have pulled up is now the root of this tree. So if we had 1, 2, 3, 4, 5, and we pulled up the node 3, then 3 would be now the middle and the root of the tree. On the left side of it, we would have 1 and 2, and on the right side, we would have 4 and 5. And in this way, we have two methods to balance search trees with the Avl methods, balanced by binary search trees with the Avl method. One is called left rotation, which is what we do if we have the nodes going to the right, like a straight line, and we pull one of them. Okay, then it's a left rotation, because we are as if we are rotating to the left, but I prefer to think of it as pulling up one of the nodes, pulling it up. And if you had a straight line going to the left and you want to balance the tree, then same thing. If we inserted the nodes into the binary search tree without doing any Avl optimization with 4, 5, 4, 3, 2, 1, then we would have all the nodes going to the left. So the way to balance it would be to pull one of the nodes on the straight line going to the left, such as the middle node. Let's pull up again. So you take with your hand a node with the value 3, we pull it up, we all together pull it up, and we get a new root to this binary search tree, which is node with the value 3. And in this way, we can find, whenever we add or delete nodes from this binary search tree, we check if the tree is not now well balanced. If it's not well balanced on the place where we are adding the node, then we balance it with the Avl method. So this was a brief intuition into Avl trees, which are balanced binary search trees.